Most document extraction pipelines make the same mistake. They spend months improving OCR accuracy while throwing away the information that actually identifies the fields. The surprising part, the problem isn't the text, it's the layout. In this video, I will show you why OCR text alone is often insufficient, how bounding boxes change everything, and will build a layout aware extraction pipeline from scratch using only free tools. As a humans, we instantly know John Doe is the name. But notice, we are not using the text alone, we are using position. What happens when OCR removes that relationship? Now we'll see what beginners said to LLM from an OCR. This is what many teams send to an LLM. Notice what is missing? We no longer know where anything appeared. His name, John Doe, DOB. We don't know the exact position of it in the image. Let's stop talking and actually see the problem. Let's install ORC CV, Computer Vision, and Matplotlib. Let's just first install it. Okay, so in Colab we have to use it like this first before PIP. So to know what is actually in the image written, we will call the loop and let's just print it. First I will need to rename my file. Let's run. Run an error. What is life without an error? So name was the problem and now I'm gonna paste the whole path so it can read it. And running again. This is exactly what happens in the real world OCR. Most tutorials show perfect OCR results, but real documents don't look like that. OCR sees shadows, decoration, text, logo, borders, signature, background patterns. The result is often noisy. Before we solve layout understanding, let's first reduce OCR noise. Let's comment this loop first. We need to create first list to store the information. And here we will call bounding box text and confidence score from result. we need to give condition first that we want result only if the confidence score is greater than 80% to get our desired result. 80% is a good mark, I think. We will append all the three bounding box: text and confidence. And we'll call the loop of that list, and we will print only the text because we need only that right now. Again an error. What is it this time? The list object has an attribute append. Okay, my spelling was wrong. Run, 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 run it, run it, run it. Okay. How long will it run now? Okay, we got the text. As you can see, we have all the text that were available in the ID. All the information, yes. But if I give this text to an LLM, how would it know that John Doe is the name? Let's comment this. I don't need this. We will print now. With text, we will need bounding box. So we will know the position of the text. And let's just print confidence score too, just for the information. And we will run now. I've already speed up this process for you all. Can you all just subscribe my channel so I can buy better computer? So this is the output. For each text we have got the position, as we can see. So to show it, we will do another method, or better we will call now CV, so we can display it better what is actually happening. Let's remove this. If the confidence is less than 80%, just continue. We will need to call tuple, and we will need to map the bounding box. And because the output was in float, as we saw, we will need to map it into integer. So why 0 index and 2 index? Because 0 represents the top left of the rectangular, we are going to show it in rectangular, and 2 is for bottom right. So we will see the result in a rectangular form, and so from top left to bottom right, CV will map all the text present in image. We need to define image variable. Image variable will read the image as what OCR did, and now we will write that into image. This is not the method. Okay, yes, I'm right. Right. Meanwhile, you can subscribe, like, share, or comment, or if any feedback you have. Oh, surprise, error again. No attribute imagery. What is this? Oh, spelling mistake. Once in interview, I was asked, what is the most complex error I have faced? I don't face complex error, I face stupid errors, such as spelling mistake. Oh, great. It is good. Where is the image? Oh, here it is. We will download it. But what happens if we add to Germany? I don't know. Okay, open. Yes, this was the image that we were working on, and CV has successfully identified all the text because of the bounding box that we did and the index 0 and 2 we gave. As you can see, John Doe is correctly identified exactly where it is. Great. So OCR didn't just find the text, it found where it lives. At this point, many teams throw away the coordinates and only keep the text. The problem isn't OCR accuracy. The problem is losing layout information. This example is simple, but production systems use coordinates, distance, regions, and document structure to identify fields. The lesson here isn't really about OCR, it is about preserving information. Once document structure disappears, no prompt can reliably reconstruct it. That is why modern document understanding systems don't just read text, they read text in context, and often context is simply location. So that is it for this video. If you have any suggestion or doubt regarding this topic, you can ask me in the comment section. Till then, you can subscribe my channel, like and share. Thank you.